Alright, here's the notes for the assignment that you're going to see today. It's lesson 9.2, Multiplying Polynomials. And yet again, this is another thing that if you put your mind to it, it's a task you should be able to conquer, as we're going to be using the distributive property, which is a previous skill that we have learned. So, let's take a brief review over distributive property. Remember, these notes are lesson 9.2. Multiplying polynomials. Okay? And what happens when you multiply polynomials is the distributive property takes place. So let's take a quick review on the distributive property and let's see how it works. What happens in the distributive property is there's a term on the outside of the parentheses, and then there's going to be multiple terms on the inside of the parentheses, just like we have in this example. So in the distributive property, that outside term, which in this case is 4, has to multiply with both terms inside. That's why it's known as the distributive property, because it distributes to each term. So we take 4 times y, that results in 4y. Then we take 4 times 3, that results in, since they're both positive, positive 12. And because we cannot add a term with a y and a term with no variables, this is as good as our answer can get. Okay? Now another example that you might see on the distributive property would be an example where we maybe have a term outside that has not only a number but also has a variable. So here's my outside term, and let's pretend that it's going to multiply to multiple inside terms, even more than 2. So let's go 3n squared. Ooh, that's an ugly squared. Plus, we'll do a regular n, and we'll also do a minus term of 9. That way you can see what happens when our signs change too. Once again, our outside term has to distribute with every inside term. So I'm going to get these arrows drawn showing that it's going to multiply with each of those. So this is multiplication, this is multiplication, this is multiplication. 2n times 3n squared. The coefficients, or the front numbers, will multiply. So 2 times 3 is 6. Then I have n times n squared. That's n times n times n. That makes a total of 3 n's. Notice that their exponents, this one being a 1, would add with the 2 to make the 3. That's what happens when you multiply variables. So we have a positive times a positive next in the multiplication for the distributive property. 2 times 1 is 2. N times n is n squared. And then I have 2n times my last term, which is a negative 9. That's a positive times a negative, results in a negative. 2 times 9 is 18. And since there is only one n being multiplied here, there's only going to be one n left. And this is as good as our answer can get, because none of my terms have a variable and an exponent that are the same. And this is actually the process of multiplying polynomials. Now, the way we will typically see this on our worksheet, let's take a look at a couple examples. Here's a good one with the distributive property. Negative w to the third times w squared plus 3w. What is my outside term? Negative w to the third. It must multiply with both inside terms. Negative w to the third times w squared. That's a negative times a positive. Results in a negative. I have 3 w's multiplying with 2 w's. That's w times w times w times w times w. That makes a total of 5 w's. And then I have the negative term times the positive term. That results in a negative answer. The coefficients of 1 and 3 make 3. And then w to the third times 1w, w, w, w times w will make a total of 4 w's. This is as good as our answer can get. Typically, the way we're going to see multiplying polynomials is a little bit different than these examples. For example, you might have x plus 1 times x minus 4. And in this example, what's happening is the distributive property is going to happen with this first variable or this first term, and then it's going to happen with the second term as well. So let me try and color code these so it's a little bit easier to say. We're going to call this my first outside term, just like the w to the third was my outside term here. It has to distribute with both of the terms in the second binomial. So x times x, that's 2 x's, it's going to be x squared. Then I have x times negative 4. That's a positive times a negative makes a negative. And then 4x is a result of x times 4. Now, we also have a second distributive property taking place here. It's going to be the 1 times x, which will leave positive 1x. And then a 1 times a negative 4, which will just be negative 4. At this point, we have the end result of our distributive property that happened with both terms. Now when this happens, these middle terms can actually combine because they both have just a variable of x in the same exponent. So I'm going to bring the first term down, x squared. Then negative 4x plus 1x will leave me at negative 3x. The minus 4, since it has no other like terms, it just moves on down. And that is how you do that type of multiplying of a polynomial. Let's do one more of those examples, and let's throw another term up front. So you have 2m plus 1 times m plus 3. We take our front term, 2m, multiply it with both terms in the second binomial. So 2m times m is 2m squared, and then 2m times 3 is positive 6m. And then we take our second term, and it distributes with both those terms as well. So 1 times m is 1m, ooh, ugly m, and then 1 times 3 is positive 3. Notice once again that our inside terms can combine. So 2m squared has no like terms. Positive 6 plus 1m is positive 7m. And positive 3 has no terms to combine with, so it stays as positive 3. This is as good as our answer can get. Okay, here's the most difficult type of example you'll see on your homework. You would have the front term as a binomial, which means it has two. It has a w, then it has a 1. Then in its back term, it's going to have 3 terms. W squared plus 2w plus 1. So this is called a trinomial. It's still the same process, but we have to multiply with all the terms in the second. So w times w squared, that makes 3w's. W times 2w will make 2w squared. W times 1 is just 1w. And then we have our second term, which has to distribute to all 3 of these as well. So 1 times w squared will leave 1w squared. 1 times 2w will be 2w. And then 1 times 1 is just 1. So since there are no more that have an exponent of 3, that term is good. This has an exponent of w to the second power, as does this. So 2w squared plus 1w squared, we've added polynomials before. We know that their coefficients are what get combined, so 2 plus 1 makes 3w squared. And we've gotten rid of these terms. We've combined them to that 1. Now we have 1w plus 2w, that's 1 plus 2. That makes 3. The variable stays the same. And since the plus 1 has nothing else to combine with, it just tags along. And this is the best your answer can get. Okay? Take some shots on your homework. Do all that you can. Give it your best shots. If you need help, please email me. First name Trevor.limley@sjsd.k12.mo.us. Thanks for listening. Have a good day.